Hello everyone, welcome to the fourth module of data analysis with Python full course. This is Sumit Shukla, senior data scientist and an educator. In this particular video, we'll be talking about end-to-end YouTube data analysis project. So let's get started. So in this particular video, we are going to look at an end-to-end project in which we'll be trying to understand all the steps of data analysis, and also we'll be applying all the learnings that we have gained in all the previous modules. So let's get started. So before we directly jump into the YouTube data analysis, we will first of all understand some basics by taking one dummy data. So let's import Pandas, because as you guys already know that for any kind of data manipulation task we need the Pandas library. So let's read in the data, and as you guys already know that for importing the data we need the particular command pd.read_csv, and here I have uploaded my data in a particular repository known as data.word, and I am utilizing the link from that platform to read in my data in the data frame named df. So let's import my data, and let's now look at the head of this data frame. Now this data is about various games that were released in past, let's say past 20 years. We have the name of the game, so we have WII Sports, Super Mario Bros. We have the platform in which it was released, in which year it was released, what was the genre, who was the publisher, and then we have the parameters like the North America sale, the Europe sale, the Japan sale, other sales, global sales, and then we have the score. So critic score, critic count, user score, user count, who was the developer, and rating. This is the data which we have. Now, the very first thing that we will be trying to understand is how to clean the data. As you guys can see that there are some errors that you guys can easily find out in this data. Number one is years of release. Now, as you know that right now this column is in float data type. You can see a .0 which is decimal point. Then here also 1985.0. Now a particular year as a column, as a feature, is considered as a categorical variable, which basically means I am considering each year as a category. So I will have some games getting released in 2006, some games getting released in 1985. So each year is considered as a category. But Pandas has loaded this particular feature or the column as float. So we have to correct it so that when we are trying to perform any kind of data analysis, we are not considering it as a float column but as an integer column, or the best would be to consider it as an object column. Oh, there is one more thing that you guys can use to understand whether to keep a column as an object column or a float column or a integer column. So if your objective is to perform any kind of mathematical process on a particular column, then better to keep it as float or integer. For example, are we going to add these 2 years? So 2006 plus 1985? No, because the addition would not make any sense. Are we going to subtract it? Maybe subtracting would make a sense, but here my objective is not to subtract. I am not going to multiply. I am not going to do any kind of mathematical operation on this particular column. And hence, we should keep this column as object, because that best suits our current objective for the data analysis in this particular data. So let's try to understand how we can convert this column. Right now it is in float. How we can convert this column from float data type to either integer or object. Let's do that. So we have df. I'll just quickly copy the column name from here, years of experience. And if I look at the D type of this column, which will eventually return me the data type of this column. It is float 64, right? But my objective is to convert it into integer or object. So first, let's try to convert it into integer. Now, Python provides us with a particular functionality known as type. So let's utilize it. Here is my column dot as type, and I want to convert it into integer. So I'll write int, integer. Now here we are getting error. The error says cannot convert non-finite values NA or infinite to integer. You guys can, this is a problem that is something you can find out while working with the data and while performing data analysis. You're trying to convert a column which is float into integer, but you are getting error that a particular column, for example, this particular column years of experience, is having some NA which is not available values or infinite values which cannot be converted into integer. Now, are we having any kind of nulls in this column? Let's try to quickly check. So how we can check it out? Dot is null. So it will return me a Boolean series which will have true and false. And in order to find out how many trues we have, how many ones we have, we'll just take a sum of this series. So dot sum. And this column is having 269 nulls. Now, what is the solution to this problem? Should I replace these nulls in order to convert it into integer, or should I directly convert it into object? If I directly convert this column into object, then instead of float, I'll get the exact same value in object. If it is not making sense, let me quickly show you. So right now, my column is, let's say 2006.0. This is a float value. If I convert this into object, it will become like this, 2006.0. And why these inverted commas? Because now I have converted this into object, which essentially or eventually means I have converted it into a string. So converting a particular float value into a object column will not make any sense because it will not solve our problem. My objective is to convert this column into something like this, 2006, without any decimal points. Now, how we can do this? There is one data type known as the nullable integer data type. Nullable, let me write it down. It is nullable integer data type. What is the meaning of this? Let's try to quickly learn about it. What exactly nullable integer data type is? So let's Google it. Nullable integer in Python. And let's try to read this document. So in working with missing data, we saw that Pandas primarily use NaN to represent a missing data. Because NaN is a float, this forces an array of integers with any missing value to become floating points. If you are listening to me very carefully, you guys would have already understood the problem. So what happens? Pandas use NaN to represent a missing value in a particular column, right? Now, since NaN is a float data type, this forces the complete column to be typecasted to a float column or a float data type column. So if any numerical column is having missing value, then it would be loaded as NaN. This is the default structure or default working of Pandas library. Now, how to convert it into integer? So in order to solve this problem, Pandas came up with a new data type known as the nullable data type, nullable integer data type, and it is represented as capital INT64. So here it is written, note that the capital I to differentiate from NumPy INT64. So it is capital INT64 with it is INT64 with capital I. Let's try to utilize this. So instead of INT, we will use capital INT64. And now you can see that I'm able to convert this column into integer. Let's try to preserve it back to the same column. I'm trying to preserve this output into the same column so that now years of release is having only integer values. So let's do that. And now let's try to calculate the number of nulls. So now I'll copy this column, copy this code, put it over here and run it again. Again, we are having 269 nulls, but it is now this column is an integer column. So that is what the advantage of using this nullable integer data type is. Now using the same logic, we can typecast all the columns which has been incorrectly loaded as float into integer. For example, all these columns which are critic count and user count. Now since they are count, that basically means they need to be in integer. So we should be converting them into nullable integer data type. Let's do that. So I'll get all the column names, df.columns, and I will perform the same operation. So for critic count, I'll use the same logic, critic count dot as type capital INT64, and I'll do this for user count. I have done a mistake. I should be selecting critic count, not the critic score. So let's do that. And now we can execute both of them together. So if I look back the data, the head of the data, you will find out that now we are having NA represented in these special brackets, but this column is now in integer. You can see all the values are integer now. Previously they were in float, right? So this is the advantage of using nullable integer data type. Let's quickly understand one example of how to convert integer into object. So let's say now I want to convert year of release, that is right now a particular integer column. So right now this is integer data type. If I want to convert it into object, I'll just say as type, and for object you can use either capital O, or you can write simply object, or you can write str. Anything is fine. So I'll use object, and now you can see that the data type is object. Let me preserve it back to the same column, and we are done. Now let's perform a quick count, and you guys already know how to create a count chart. We can use the count plot from Seaborn library. So let's do that. Import Seaborn as SNS, import Matplotlib.pyplot as PLT. Now let's plot SNS.countPlot, and we are interested in plotting years of release. And here we go. Let's execute this. Okay. So float argument must be string or a real number, not any data type. Now, the reason we are not able to plot it is because this column is having nulls and Seaborn is not able to recognize any data type. So what we will do, we will drop only those values. So dot drop NA, and let's execute it. And here we have, so right now you can see that there is some problem. I'm not getting the plot that I want to basically have. Basically, I'm interested in getting a plot where I'm having in the x-axis I have year of release, and on the y-axis I'm having the count. So the problem is I haven't written x over here, and here we have the plot which we are interested in. How to remove this particular overlapping? We have already learnt about it. We will just rotate the x-text. So plt dot x-text rotation is equal to 90 degree. And here we have the plot. So now you can see it is very clean, and these two are the years, which is 2008 and 2009, in which highest number of games were released, right? So this is how you can tackle the problem of data type conversion, also known as typecasting. We will see one more example in which we'll be using a special function to get this done. So right now we have used the function as type. Let's talk about one more function which is really useful to perform the typecasting from object to any numerical column. Let's talk about that also. So let's now utilize one more sample data, and let's talk about a very special function known as pd.toNumeric. So here I have already uploaded one file known as telecomchurn.xlsx. I'll copy the path and load it. So df is equal to pd.read_excel, and we will paste the path. Let's look at the head of the data. So here we have this particular data. Now if you guys closely observe, here in this data we have tenure as one of the numerical column. Then we have monthly charges, total charges. If I look at the data type of all the columns, D types, in that case, senior citizen is an integer data type, which is wrong because it is a binary column, which basically means 0 means no, 1 means yes. So we will replace these values with no and yes because everything is no and yes. The second is tenure, which is an integer, that is correct. The third one is monthly charges, which is in float, that is also correct. Total charges is an object, and this is wrong. So let's first of all tackle this problem, senior citizen. So what we will do, df senior citizen dot replace, I'll replace my value 0 with no and 1 with yes, and I'll do this in place is equal to true. So now let's look at the column senior citizen, and here you can see that we have no and yes. So we are done, right? Previously it was all zeros, basically means 0 means no, 1 means yes. Now we have no and yes. The second problem is with this total charges column. So the first of all, let's try to understand why total charges has been loaded as object. So df total charges, and we will try to convert this into, let's say, float. Let's see what happens. So here it says could not convert a string to float, and this is what it is not able to convert. What this known as? This is known as a white space. What is a white space? White space is nothing but a empty string. For example, this is a string which is having some characters. So here each term or here each alphabet is a character, right? But I can have a string like this also, right? Now this does not have any character, so no character. So this is known as a empty string. Empty string, also known as a white space. White space. So this is the problem that this particular column is having. In the total charges column, it is having white spaces. Now how we can deal with this? There are two solutions to deal with this problem. Number one is, first of all, I replace all these white spaces into the Pandas recognized nan, which is np.nan. The second solution is use pd.to_numeric with the error attribute. Now what is the meaning of this? Let's try to understand this. We will be using the second approach where I am going to use pd.to_numeric with the error attribute. Let's try to understand this. This is how we do it. pd.to_numeric. I want to convert this column into, and let's run it. So pd.to_numeric, this particular function automatically converts a particular object column into the numerical column. Now, when I say it converts into numerical, based on the content of the column, it will identify whether to make the conversion as float or integer. For example, right now, if I look into the total charges column, since the content of this column or the values of this column is in float, so this function pd.to_numeric will automatically identify that the conversion has to be made into float. But right now we are getting error. It says unable to parse the white space. It is not able to convert the white space into either integer or float. How to do this? So this particular function comes with a particular parameter or attribute known as error. Before we use it, let's quickly read the documentation of this. So if you want to read the documentation, just write help. I want help regarding pd.to_numeric. And here we have the documentation. So this particular function comes with a parameter error. Now error can be, or errors with the S can be ignore, raise or coerce. If raise, then invalid parsing will be raised as exception. Right now it is raise and you are getting an exception. If coerce, then invalid parsing will be set as nan. So wherever pd.to_numeric is not able to convert a particular value into numerical format, it will set that value as nan. Now that is what we want, right? If I want that if this particular value is not getting converted into numeric, it should be converted to nan, right? Because a white space essentially mean nan, right? So this is what I want to do. What is the meaning of ignore? Then the invalid parsing will be return the input, which basically mean I am not going to consider that complete row. And that is, I do not want that to happen. So we'll use error is equal to coerce. And now you can see that I'm getting float 64, right? Let's preserve it back to the same column. And let's check the data types of various column now. And here you can see that we have three numerical columns, tenure is in integer, monthly charges, total charges are in float, and everything looks good now, right? So this is a part of data cleaning that I was trying to explain to all of you. Now, once we are clear with this, once we are clear with how to make our data into correct data types, because once my data is in correct data type, then it will be quite easy for us to perform various analysis and plot various columns. Now let's try to understand, or let's start discussing about how to perform end-to-end data analysis. And for basically understanding the process of end-to-end data analysis, we'll be taking the example of the YouTube data. So I was able to download the data regarding YouTube uploads, the YouTube India uploads from the Kaggle website. And you guys can also find it out in Kaggle. If you just write Kaggle YouTube data India, it will return you, it will take you to a particular web page where you have the data regarding all the uploads that were made on the YouTube platform from the India region. So we are going to use that data, perform the analysis, and we will try to answer some hidden questions, or we will try to find out the answers of some questions from the data analysis that we will perform. So let's get started. Now let's start with the YouTube data analysis, and here we are going to perform the complete end-to-end data analysis. We will try to find out some interesting insights from the data, but before we can actually perform data analysis, we have to clean the data. So the complete process of data analysis will be divided into 3 steps. Number 1, to perform data cleaning and data understanding. Number 2 is to formulate the problem statement or the hypothesis. And number 3 is the analysis, where we will be performing data visualization, or we'll be trying to slice and dice the data to get our required answers. So let's start this. First of all, we will load the data, pd.read_csv, and I have already uploaded my data in this particular repository known as data.word. So let's upload it. So here's my data. Now let's first of all understand the data. We have video ID. This is a unique ID given to each video. So whenever you upload your video into YouTube, YouTube assigns a unique video ID, and that is what we have over here. Trending date. Now whenever you upload your video, there is a upload date. So on the date on which you have uploaded the video, that is your upload date. And this is what we have, the published time. Published time is having the date and the time. I'll talk about how this time has been represented, but published time talks about the date and the time on which your video was published over the YouTube platform. Trending date is the date when your video came into the trending list. Now, those of you who are very familiar with YouTube platform, and I assume that all of you are very familiar because you are listening to me on the YouTube channel. So there is a trending list, and this trending list is specified, or it is different for each region. So let's say if you are listening to me from South India region, then the trending list would be different for the South India region, and the trending list will be different for the North India region. And specifically, if I talk about the region in the Bihar side or UP side, the trending list will be different, or and in the side of Gujarat or Mumbai, it would be different, right? So trending date talks about the date on which your video listed on the trending list. Then we have the title of the video, the channel title, the category in which the video was loaded. We have tags. So while you upload the video, you have to provide some tags regarding your video so that the YouTube algorithm can understand what is all about, or maybe what is the content of the video. So tags are really useful for the algorithm to categorize your video into some category. And then we have views, likes, dislikes. Then we have comment count, thumbnail link, comment disabled. So when you uploaded your video, have you disabled the comment? So if it is true, that means comment were disabled. False means it was not. Rating disabled, again, is are you giving the option to your viewers to click on the like and dislike button? So if it is false, that basically means the particular viewer can click on the like and dislike button. If it is true, that basically means the person cannot do that because that has been disabled. Video error. So is there any error in the video, or the video has been removed? So you will get a true over here. Description of the video, the complete description section is presented over here. Now this is the data which we have been provided with. Now the very first thing that we will do is to understand whether the data has all the columns into correct data type or not. So let's quickly do df.dtypes. Now we have trending date in object. So the very first problem is the trending date column. The trending date column is in object. And the second problem is regarding, if I talk about publish time, this is also an object. So publish time is also in object. So these are the two problems that we have. If you look carefully for all other columns, for example, all these columns, comment disabled, rating disabled, video error, these all columns are having the content as true false. So they have been loaded as Boolean. If I talk about description, it is an object because it is a complete string. Then we have views, likes, dislike, comment count. These are all the integer values. Then we have the title, video ID. Since video ID is in alphanumeric, it has been loaded as object. So all other columns are in correct data type. We have only these two columns which are incorrect. Now what is the correct data type of trending date and publish time? Well, that is Pandas date time format. It should be loaded in date time format. Now how we can do this? So we have learned about pd.toNumeric and what is the objective of that function. So we have already learned about pd.to_numeric, and the objective of this function is to convert a object column into a numerical column. And this particular function is intelligent enough. So object column into numerical column, and this function is intelligent enough to recognize the correct data type of the numerical column based on the content of the column. So if the column is having floating values, then it will be converted to float 64. If it is an integer, then it will be converted to integer 64. There is one more function which is known as pd.to_datetime. Now the objective of this particular function is to convert the object column into the Pandas datetime format column. Pandas datetime format column. This is what this function will do. Let's try to utilize this function. We will first of all try to convert the trending date. So pd dot to underscore date time. I want to convert the trending date column, and let's run it. Now it is returning me error. It's saying month must be 1 to 12, 17, 14, 11 present at position 0. What's the problem? Let's go back to the data. Here, the trending date is 17, 14, 11. Now what is the meaning of 17? What is the meaning of 14? What is the meaning of 11? The function pd.toDateTime can convert a object column into a pandas datetime column if the dates presented in the datetime column are in standard datetime format. Right now, this column, trending date, is having the date, but it is not in standard format, and that is the reason my pandas datetime function, the conversion function, is not able to understand what is the meaning behind 17, what is the meaning behind 14, what is the meaning behind 11. So we have to declare that while we are trying to convert this column, trending date, into the pandas datetime format, we have to also provide this function datetime with the declaration regarding what is the meaning of 17, what is the meaning of 14, what is the meaning of 11. Now if I ask you, all of you, to recognize this, then all of you can simply say 17 basically means year, right? 17 is year, because here also you can see 2017. So 17 is definitely my year. What is 14? Now 14 cannot be a month. A month can be between 1 to 12 only. So 14 is definitely my date. And what is 11? We are left with the month. So 11 is my month. Now we are able to understand that 17 is my year, 14 is my day, 11 is my month. I have to tell the same thing to this particular function, and then this function would be easily able to transform or typecast this column into pandas datetime format. Let's do it. So here we have an option known as format. Format is equal to. Now how to declare the format? You guys can use this amazing website known as strftime.org, and this will help you with all the formats which we can use to declare all the codes which we can use to declare the format in the pay.toDateTime function. The very first component of my format is year, and year does not comes with the century. So here we do not have a century, we just have the year. So how we can declare it? For year without century, we have %y. Let's write it down over here. So %y. This is followed by a dot. So let's put a dot. Then we have 2-digit day. So 2-digit day. Where is day? We have here we have day. 2-digit day is represented as %d. So let's put %d over here. And then finally we have the month again in 2 digits. So 2-digit months, we have %m. Let's do that. %m, and let's run it. Now you can see that we are able to convert the column into datetime column. Let's preserve the values back to the same column. And now trending date column is our datetime column. Let's quickly cross check df.dtypes, and here we have datetime column. Now let's target publish time column. Publish time column right now consists of two components, the date and the time. Time is in very weird format. There is a Z. Now this represents the universal time format UTC. So let's ask Google about UTC. What is UTC format? And the unit. So the unit of UTC format is the Z. So here we have UTC format, which is universal time coordinated universal time, and this particular universal time is having a unit of Z. Let me just quickly search where I can time zones. Okay, let's quickly just Google it directly. Unit of UTC time format or UTC time zone. So here you can see military name is Zulu. Zulu is basically we are using the unit Z. I can just quickly go to, let's go to Google, and Google will help us with the correct answer. Unit of UTC time zone. Okay, so here I might be writing it wrong. So what is Z in UTC time? So the Z stands for 0 time zone, as it is offset by 0 from the coordinated universal time coordinate. It is basically, you can assume that it is like a reference point. The time zone using UTC is something denoted like this by the letter Z, a reference to the equivalent nautical time zone, which has been denoted by Z. So you guys can read about it, but the point that I'm trying to make right now is we have the date followed by the time, which is in the UTC time format. Let's try to convert this column into Pandas date time format. Now, since this column or the values or the content of this column is in very clean format, so 2017-11-12, since the format of this object column is very clean and is standard, I do not have to make the declaration. So all I have to do is pd.to_datetime df and this column, and let's run it. Now you can see it has been converted with the time in UTC. Let's preserve it back to the same column. And now if I quickly check my date types, here you can see that trending date is in date time, published time is also in date time. If I look at my data, now here we can see that trending date is having the trending date in proper date time format. Published time is also having the date and time. But in the published time column, so as per the analysis right now which we are going to perform, I will not be doing anything with the time, or maybe I can put time in a different column, but right now I want to fetch the date from the published time column. Now if your column, there is a very good function that comes with the Pandas datetime format. Let me tell you that. So if a column and the data frame is in Pandas datetime format, then we can use, so let's say my column is published time. Now I know that this column is in Pandas datetime format, right? We know that this column is in Pandas date time format. Now if I put this dt and dot, so this dt is basically a successor which can help you to perform extraction of various components of date and time. So helps in extracting various components of date and time. And after this I can write the name of the component which I want to extract. So let's say I want to extract only the date, so I can write date. If I want to extract time, I can write time. If I want to extract year, I can write year. Similarly month, similarly day, similarly hour, minutes, seconds, and I can extract all the components as I want. Let's quickly test this in Python. So here we have the column df. I hope the publish time, yeah, publish time, that's publish time dot dt dot, let's say I want to extract date. Now here you can see this has extracted only the date. What if I want to extract time dot time? So here we have time. Let's say I want to extract seconds. Okay, second. So we do not need s, second. Let's say I want to extract only the year. So year, right? So this is how we can use the dt successor to perform extractions in a very easy manner, right? Let's create two columns now, one with the date and one with the time. So I'll create a column publish date, which will only have the date component from the publish time column. So let's copy this, put it over here, and I want date. Let's create one more column, which I will call as publish time, and this will have publish time dot time. Let's run it. Now if I look at the head, we now have two columns. One is trending date, publish time, which is having only time, and then we have a new column known as, so this is my new column, publish date. Now if I quickly look at the d types, df dot d types, we have trending date. Okay, we have trending date, which is in date time. We have publish time, which is in object, and we have publish date, which is also an object. Now there is one thing that we have missed. When we use this dt regressor, it returns the column, or it returns the series in the object format. So we have to again typecast. So in order to make the correction, I have to go back and reload the data. So let's reload it. So here we have the data. Let's run this command. Then let's run this command. Then over here, we will perform pd dot to underscore date time, and I'll pass this value. Similarly for this, pd dot to underscore date time, and we'll pass this particular value. Okay, so time we cannot convert into date time, so let's keep it as it is. Anyhow we are not going to use it. Now let's look at the output. So here we have the output. And let's look at the D types. Now we should have trending date and date time, published date and date time. Now we are done taking care of the date time columns. We are done with data cleaning. Now we can start with the hypothesis formulation and data analysis. So let's do that. Now let's formulate the hypothesis, or maybe the problem statement. Here we are going to analyze two things. Number one, we are going to check the pattern behind those videos that were trending on the same day as they were uploaded. So pattern behind those videos that were trending on the same day of the upload. Second is the pattern behind the T-series YouTube data. So as you guys already know, T-series is the channel with highest number of subscribers in India and even in the world. So T-series analysis about how they upload the video, at what frequency, and at what maybe at what season they upload the video. So these are the two things that we are going to perform as of now. Let's start with the very first thing. Before we do that, let's look at the video with highest number of views. So in order to look at the video with highest number of views, I will just quickly do a sort. So df dot sort underscore values, and I want to sort my data on the views column. So df, no, we do not need to write df, we'll just say views, and we can also say by is equal to views, and I want to do it in descending. So how is equal to, or ascending is equal to false. And here we have the result. The video with the highest number of views is this particular video, YouTube Rewind the Shape of 2017, and this video got these many views. But there is something which you guys should look very carefully. The same video is available over here also. YouTube Shape of Rewind the Shape of 2017. The same videos over here also. So this video has been in my presented in my data for 3 times. Why? What is the reason? Let's look at only few columns to understand the reason why we are having the same video for multiple times. So I'm going to look at the video ID, df.columns. So let's look at the video ID, the trending date, the title, and then we are going to look at views, likes. So let's look at only views, and finally the published date, which I can put beside trending date. If I look at this data, and if I look at this data of for this video only, this particular video, let's filter the data for this video only. So df video ID is equal to this. So if I look only the data for this video, which is the video that is having highest number of views in my data, you can see that the data which is presented to us is a cumulative data. This video was published on 6th of December 2017. It was on the trending list for 7th, 8th, 9th, 10th, 11th and 12th. And you can see that the final row is having the final views on the final day of the video on the trending list. So there are two things that we can understand from this data, the way the data has been presented to us is number one, the number of times a video ID, the number of times we have the video ID in the data, it represents the number of days the video was on the trending list, right? This is the very first thing we can understand. Second thing is the final row for each video ID is the row with the final number of views, likes, counts, and all other parameters These are the two things that we can understand after this particular analysis. How we can get rid of all these rows and how we can only get this particular row. So what you guys can also do, I'm just leaving this particular task for all of you. I'll just put it over here. Create a new column with each video ID and the count of maybe the number of days it was trending. So I can just give you a quick hint. If I do df video ID dot value underscore counts, I will get how many times a particular video is basically presented or is available in my data. Hashtag name question mark, these are the videos which does not have any video ID, so we will ignore this. But from here you can see that I'm having the count or maybe the number of days this video ID was on the trending list. So if I ignore the first row and if I convert this into a data frame, pd dot, or let's do a quick reset index dot reset index. Now this is the data frame, or maybe this is a result that I can use to merge with this data frame, the main data frame, and I will eventually get one additional information regarding how many days the video was on the trending list. I'm leaving this task for all of you. What we are interested in doing is I want to remove all these rows and only get the last row for each video ID which has been duplicated. So what I want to do is preserve the last row for each video ID that has been duplicated. This is what we want to do. Before we do that, let's try to check if the data is having natural duplicates. What is natural duplicates or complete duplicate? So let's take one example. Let's say I'm having this data. Here I'm having video ID. Let's say this is the name of the video, the views, and the date. Let's say the video ID XX2156. Name is, let's say, T series. Views is, let's say, 1000. Date is 12/12/2023. If I'm getting the same row with the exact same details, now this is the example of completely duplicated row. This is the example of completely duplicated row. So first of all, I will check if we have completely duplicated rows, and if we have them, we will remove them, we will keep only one of them. If yes, keep one. Second is the particular problem that we have discussed. Out of all the rows for which the video ID has been duplicated, I'll keep the last row. And why last? Because the last row is having the cumulative details. Number of views, counts, comments, everything is cumulative in the last row. So these are the two things that we are going to do. Now the function that we are going to use is drop underscore duplicates. This is the function we are going to use. Now let's understand how we can use this function to tackle both the problems. So what we will do, we'll first remove complete duplicated row. Complete duplicated rows. So df dot drop underscore. First of all, let's look at the help of this function. Let me just quickly explain you how this function looks like. Duplicates. So this is the function. Now this function takes input as, so here we have the parameters subset. Now if I want to look at the duplicates on a certain column, then I'll use the parameter subset. So if I just want to look at the duplicate on one column, let's say video ID, I'll put subset is equal to video ID. Then it will look for duplicates in the video ID column itself. As of now, my consideration is to look for all the columns where the complete row is a duplicate of another row. So subset will be all the columns. By default, it uses all the columns. So we do not have to declare it. Keep first, last, false. By default, it is first. So as of now, we are worrying about the complete duplicate row. So if I keep first or if I keep last, both are same. So we are not worried about this. In place is equal to true. In place is equal to false. So are you interested in removing the duplicates in the same data frame? Are you interested in performing the operation in the same data frame? You can keep in place is equal to true. Let's use it quickly to drop all the complete duplicated row. But are we having any complete duplicated row? Let's check. Df dot duplicated. Df dot duplicated. And I think we need to use sum also. Yes, we are having 4,263 rows which are exactly same of each other. So we will drop them. Df dot drop underscore duplicates. And I'll do this in place. So in place is equal to true. Now if I run it again, we should not be getting any answer. We should get 0. And we have 0. So we have tackled the complete duplicate row. Now the second problem. Out of all the cases in which video ID is duplicated, I want to keep the last row, right? So let's quickly do that. Df dot drop underscore duplicates subset is equal to the video ID column, and I want to keep the last. So keep is equal to the last row, and I will do it in place. So in place, you guys can preserve it in a new data frame also, but I am doing it in place. In place is equal to true. And now my data frame is free from all the problems. So if I just need to cross check, I'll just copy this code, put it over here, and I should get one row, the final row for this video. So I am having one row, and is this the final row? So the last trending date is 2017-12-12, and this particular result also, the last date is 2017-12-12. So the operation has been correctly applied. Now my data is free from duplicates. I'm having exactly one row for each video ID, which basically means now we can start the analysis. My data is now 100% clean. I would not say 100% clean. There might be some more data error and some more problems. But as of now, based on our hypothesis or our problem statement, my data is clean. So let's now start the analysis. So now the particular problem statement that we were trying to solve was to analyze the pattern behind those videos that were trending on the same day as they were published. Now, how to find out those videos that were trending on the same day as they were published? Now, this is the question. The easiest answer is wherever the published date and trending date are same, we will call that particular day, or we will call that particular video as the same day published video. So wherever the trending date is equal to published date, that is the same day trending video. Now here we have done a small error, that before we have done this particular operation, we should not have done it, because let's say a video was published on 2017 12/12 and it trended only for 1 day, or maybe let's say 2 days. Then in that case we haven't preserved the first row, we have only preserved the last row, so that would be a problem. Let's do one thing. Let's go one step back. We will do this operation once we are done with this analysis, and then we will do this operation for the T-series data one. So what we are going to do, we are going to again run the complete code till that point. Okay, let's go back over here. This is my, let's run it. Then let's run this one, then this one, then this one. Finally, we will run this one. And now we will not run this one. This command will not run. We will come back to this point. So let's just put them as comment right now. We'll come back to this point. Let's now perform this operation. So I'm going to filter my data wherever the published date is equal to the trending date. Now this is the particular data, or this is a particular data which we are interested in. So wherever published date and trending date are same. So here you can see the trending date is 2017 11/16, and here also the published date is 2017 11/16, right? Let's preserve this in a variable known as same_day. So this is my new data frame with all the videos that were trending on the same day. So same_day dot head. Now we will do a quick count, like how many channels are having the same day trending video. So the same day channel title and dot value_counts, and here we have these 4 channels with highest number of videos that were trending on the same day as it was published. Let's look at top 20 only, and these are the results for top 20. Adda 247, Wi-Fi Steady, Mahindra Guru, Steady IQ Education. These 4 channels are having highest number of same day trending video, which basically means as soon as they publish the video, it became trending. And Adda 247 is having 48 such videos. What is the reason behind it? Let's quickly go to their YouTube channel and let's check it out. So first of all, we will look at Adda 247. Let's open it. Then we have Wi-Fi study. Wi-Fi study. Let's open it. Then we have Mahindra Guru. Let's open this. And then we have Study IQ Education. Let's open this one also. Now if I look at Adda 247, you can see that they have some scheduled videos, scheduled live streams. These are the previous live streams and these are upcoming. So this is at 2 p.m. today. This is at 3:30 p.m. today itself. This is 5 p.m. today, 6 p.m. today, 7 p.m. today, 8 p.m. today, and then till 8 p.m. they have the upcoming live streams for today. Then for tomorrow, they have a live stream tomorrow, and so on. So they have a series of scheduled live streams. What about Wi-Fi study? For Wi-Fi study, again, these are scheduled for 9/1/23. Basically means this is for I think the next month at 7 a.m. and these are all other streamed videos that is streamed previously. Do we have upcoming? So here is one upcoming only, and I think they don't have any upcoming as of now. Okay, they don't have any upcoming. Let's look at Mahindra. So Mahindra is 2 live videos are currently running. They have upcoming live streams. Again, the same pattern for the same day, 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 9 p.m., 10 p.m. and so on. Various live streams, series of live streams scheduled for today. For Study IQ Education or Study IQ AIAS, again upcoming live streams at 5:20 and 7 p.m. And then there are past live streams which happened 1 hour ago, 4 hour ago, 18 hour ago, and series of live streams. Now, one common pattern which you can find out after looking at all these YouTube channels is they are doing a very frequent live streams. Now, what happens in live stream? Let's understand the strategy. So if I consider this plot, which is having, let's say this is time and this is views, then when you do a live stream, you get significant number of views at a very small time interval, and then it becomes constant like this. So this is the graph that you will get if you do a live stream, and this is the time, this is the portion. So this particular portion defines the duration of live stream. Duration of live stream. But if you upload a video, then something like this happens. You get a very linear increase in the viewership, and then it becomes steady, like maybe the video becomes trending, and then it becomes steady like this. So this is a kind of graph you get when you upload a video. Now this is the advantage of live stream advantage. So when you do a live stream, you get a significant amount of viewership in a very short duration. And this makes the algorithm put your video in the trending list. And that is the reason you might have seen YouTubers like Carrie Minati are doing a good number of live streams, because when you do a live stream, you are basically getting very good viewership in a very short duration. So this essentially helps the algorithm to understand that, okay, your video is doing very good. So the algorithm puts your video in the trending list. So now I hope you guys are clear with the very first question, why a particular, or maybe why these 4 channels, the top 4 channels that we found out, are having so many same day trending videos. So the day they uploaded their video, or maybe the day they did their live stream, the same day their video became trending. Now let's understand, or maybe let's solve the next question about how T-Series is uploading their video. So T-Series analysis. Before we start the T-Series analysis, we will quickly perform the operation which we have not done. So I'll preserve the last row of each video, and then we'll filter the data for T-Series. So T-Series is equal to df channel title is equal to T-Series. Now let's check how many rows we have in T-Series. So we have 62 rows, which basically means T-Series has only posted 62 videos. Let's look at their head. Now what we are going to do, we are going to check the monthly upload of T-Series. So in total, T-Series has only uploaded 62 videos. But what was the frequency month-wise? So from the published time column, we will extract, from the published date column, we will extract the month. So T-Series month is equal to T-Series published date and .dt month. I hope you guys now know why I have used dt.month. And let's now do a quick value count. T-Series month dot value underscore counts. Now in the month of February, it has posted 11 videos. March it has posted 10, December it has posted 9, January it has posted 9, and for few months the video has not been posted. So let's write down the observation. For month February, 11 videos were posted, March 10 videos, and if I look at January, February, March, April, or maybe from December, January, February and March, you can see that it has posted around 39 videos, right? So 10, 20, 30 and 39 videos, which is around, let's assume 40, and total videos are 62. So you can see that a good amount of videos were only uploaded on in the month of December, January, February and March. Now, why? The very first reason that you guys need to understand is T-Series is a entertainment channel, which basically means it uploads musical videos, it uploads maybe the content related to Bollywood movies and so many songs, right? So these 4 months in India are filled with, or maybe it is heavily loaded with all the festivals and the wedding season. So guys, right now what I am doing is I am trying to correlate the reality with the result that I've obtained in my data, to make sense out of the data, to make some inference. So the inference that I'm able to derive, and please remember, my point of view, my reference on my inference can be very much different from yours, because I'm using some logic, you guys can use some logic. So it is completely fine if we both are different, but the point that we both are trying to solve is to understand why this thing happened. In the same day trending video, the same thing we did. To find the answer, we looked at their YouTube channel and then we were able to find out something interesting. Right now, why they have uploaded so many videos on just these 4 months? We are trying to correlate the data, the result with the reality. Now the reality says in India, because this is Indian data, so in India, your month December, January, February and March, these are heavily loaded with very good amount of festivals. So we have festivals, we have the Valentine Day, we have the wedding season, and due to all these I would say due to all these happening days in all these 4 months, YouTube has, or T-Series has uploaded so many videos, because T-Series is basically the entertainment channel. I can prove this. Let's look at the data only for month 2. So T-Series month is equal to 2. If I look at the data only for month 2, we should be able to get some romantic song, because this is a month of Valentine's Day, right? So we have Binte Dil, we have some song from Hate Story 4. You guys already know what is Hate Story 4 is all about. We have the song Sanu Ek Pal Chan. We then have Nit Khair Manga, again a romantic song. So you can see that in this month they have organized the videos in such a way that it basically correlates with the sentiments of the Indians and the particular season, so that people are trying to listen the same songs or trying to watch the same kind of video in which they are in the mood, the current mood. If I look at 12th, the December month, and now all of you guys know that in the month of December, India gets so many weddings, right? So there should be a song which should be a party song, right? So here we have a mixtape, Punjabi mixtape. Now since it is party, Punjabi mixtape is getting released. Again Punjabi mixtape, again a Punjabi mixtape. Some DJ song, Guru Randhawa Lahori. If you go back to year 2017, Lahori song was a very famous song at that time. Yo Yo Honey Singh Dil Chori, again a very good party song. So you can see 2 party songs and 2 Punjabi mixtape. They have strategized their uploads in such a way that it matches the requirement and sentiments of the Indian, right? If I look at the month of March, again, what is special about March? It's Holi. Again, we should get a dance song, because when we play Holi, we listen to some party songs. So here we have Mundia song. Again, it is an item song from Bagi 2, Mundia. Then we have Patola. Then we have, so here we can see we have 2 party songs, Mundia and Patola. So the point that I'm trying to make over here is, we have seen everything, is the reason T-Series is posting so many videos on these specific months is because their genre is entertainment, and these are the months in which India or Indians are in the entertainment mood, are in the party mood. And the reason is, number 1, we get so many festivals. So we have Christmas also, we have holidays also, students get the winter vacations. Then we have New Year, we have Valentine days, we have so many weddings happening. Then we have Holi also. So all these things are happening in these 4 months, and that is the reason T-Series has tried uploading most of their videos in these 4 months. If I quickly look at the percentage, then we'll be able to see something very interesting. So how we can look at the percentage? I'll just normalize this. Normalize is equal to true, and I'll multiply it with 100. And here we have the result. So 17.74 plus 16.12 plus 14.5, 14.5 plus 14.5. So the total is 62.82. So 62% videos they have uploaded in these 4 months, and rest in all other months. Now, if you carefully observe, for January, February, March, and then April, May, and June, they have the video uploads. July, August, September, and October, they do not have a video. Now, there are multiple reasons around it. One particular reason which I can think of is the floods. You can see that in India, due to the season of rainy days, in July, August, September, India gets a lot of floods in various regions, right? Due to which T-Series know that this is not the time of entertainment, and they know that even if they upload a video, it is not going to work as expected. It is not going to reach as many people as they want, because the India is suffering from some kind of problem. So they stick to not uploading a video, making sure that their efforts are not going in vain. And that is the great strategy used by T-Series to make sure that they are the most popular entertainment channel in India and most subscribed channel the worldwide. So that was all about this particular video. I hope you guys understood the process of how we performed end-to-end data analysis. We talked a lot about how to perform data cleaning, and then we performed the data analysis process in 3 steps. Number 1, it was data cleaning and data understanding, followed by problem statement formulation and hypothesis formulation, and then the third was data analysis. Now you guys can extend this to the T-Series Bhakti Sagar channel also, and you guys can extend it to any depth you want. So I have just shown you a very limited analysis, but if I keep on doing this thing, it would take me around 8 to 9 hours to completely analyze this data. But I leave this to all of you. I will provide this data to all of you in the description section. You can utilize this, you can play with this, perform your analysis, and don't forget to comment your analysis on the chat section, because I read all the comments. So hope to see you guys in the next video. I hope this module was informative and really useful for all of you. If you like this video, give it a big thumbs up, share it with your friends, and don't forget to subscribe to our Scalers YouTube channel.